In the previous video, we learned that how we can draw the truss plan for a rectangular shaped building. In the previous video, I have completely shown you that how to get this truss plan for my rectangular building, which has a plan size of 40 feet into 30 feet, and my truss size taking soffit as 2 feet was 44 feet into 34 feet external. Okay, now in this video we will learn that how to design the individual trusses for the loading. Okay, that is to get the sizes for the truss. For this truss plan, I have three types of trusses, that is T1, T2 and T3. Okay, this is the T1. If you want to better understand the concept, you have to watch my previous video. I will provide the link to that video in the description or at the top of this video. Okay, so truss 1, you can see the length of the truss 1 is 34 feet. Okay, truss 1 is measured from this point up to this point. So truss 1 is length of the bottom chord for the truss 1 will be 34 feet. Okay, so bottom chord of the truss 1 will be 34 feet. So let's draw a line equal to 34 feet on the plan. Okay, so this is the bottom chord of my truss T1. Okay, now we have to decide the rise of the truss. Okay, so for the usual cases, the rise of the truss should be 6 inch to 7 inch in 1 feet. Okay, which is appropriate for the clearance of the snow on the roof of the truss. In this video, in this example, I will take the rise equal to 6 inch per feet. Okay, so this is a base is 34 feet, half of 34 feet is 17 feet. Okay, so at 17 feet you will draw a vertical line whose length should be, since I'm taking the rise as 6 inch in 1 feet, so for 17 feet the rise will be 8.8 feet and 6 inch, that is half of 17 feet will be my rise of the truss. Okay, so take the rise as 8 feet 6 inch, that is king post height or length should be 8 feet 6 inch. Okay, this is, after that you will join king post with the bottom chord and you will get the two rafters of the truss. Okay, so these are the two rafters of the truss. You can find their length from the by using the measure command. Okay, so length is 19 feet. Okay, king post is 8 feet 6 inch and bottom chord is 34 feet. Okay, I have taken the rise of the truss that is in 6 inches in 1 feet. You can take up 6 inch to 7 inch in 1 feet, that will be appropriate for the clearance of the snow loading. Okay, after that we have to get the inclined and the vertical members for this truss. Okay, so since from midpoint up to the edge is 17 feet, because total base was 34 feet, so I will divide this 17 feet into 4 equal gaps. Okay, if I divide 17 into 4 equal gaps, each gap will be 4 feet 3 inches. Okay, so I will draw a vertical member at 4 feet 3 inch to divide this gap into exactly 4 equal parts. Okay, so gaps between these verticals, okay, should be between 4 to 5 feet. My gap is 4 feet 3 inch, so it's appropriate. You can take less spacing if the loading is more. Okay, here I am taking as 4 feet 3 inch. Okay, so I will take the offset command. Second. Okay, select from this line 4 feet 3 inch. So this will be my first tie, after that second and third. Okay, similarly for this side, 1 2 and 3. Okay, trim these using the trim command. Okay, so gap between these is 4 feet 3 inches. Okay, you can check the gaps. Okay, appropriate is it should be between 4 to 5 feet. Okay, you can take 5 feet, its loading is less. If loading is more, decrease the spacing. Okay, after that, join these to draw the inclined member. Okay, similarly for this side. And this side. Okay, so this completes my truss 1. Okay, T1. This is my truss 1 and they are two numbers. Okay, now you have to decide the section for this individual trusses. You can also write the gaps between. Okay, it's 4 feet 3 inch, and you can find the lengths of the each individual members using the measure command. Okay, you can find for every member. You can see king post is 8 feet 6 inch, the first inclined member is 9 feet 6 inch, second vertical is 6 feet 4 inch, and the second inclined is 6 feet, and approximately for each you can find the lengths for each member. Okay, let us decrease the scale for this. Okay, so this is 4 feet. You can also show the length of the rafter on this. Second for. Okay, so our rafter is 19 feet and king post is 8 feet 6 inches. Okay, and you can find out the length of the rest of the members using the measure command. Okay, in the AutoCAD. Okay, now you have to decide the section for these individual members of the truss. Okay, so section will depend on the loading which your truss have to bear. Okay, you can take one thing, you can export this file into STAAD Pro, and then you can design your trusses. Or if you have already good experience about this steel structures, you can decide from the structures in your a local area that what type of sections they have used, so you can then appropriately take the sections. Okay, if the loading is heavy, then you have to go for the channel sections, and if the loading is less, you can take less weight sections like the angle section or the hollow sections. Okay, here in my case the loading, snow loading is not much, so I will take less weight sections for this. So I will take angle sections for my rafters and bottom chord. Okay, so let us take for rafters, for two rafters king post, I will take ISA, that is Indian Standard Angle, 50 into 50 into 5 mm. Okay, I will use this for rafters, king post and bottom chord, that is ISA for the king post and for the bottom chord. Okay, so for these 4, that is for, but not single, I will take it as double ISA. Okay, that is 2 ISA 50 into 50 into 5 mm. That is double angle I will use for the rafter, the top one, two rafters, the king post and the bottom chord. Okay, that is 2 ISA 50 into 50 into 5 mm. If your loading, snow loading in the area is much higher, you can go for the ISMC, that is for the channel sections, and you can take a, channel section. Better is to design the section in the STAD Pro, or if you have good experience, then you can decide the section, that what type of section I can take. So you can take ISMC 100 if the loading is, snow loading is more, but here in my case the snow loading is much less, so I will take 2 ISA 50 into 50 into 5 mm for the this rafter, king post and bottom chord. Okay, you can also export the file to the STAD Pro to design the section, which I will show in the another video. Okay, and for these, that is vertical and the inclined, I will take the section as ISA 45 into 45 into 5 mm. Okay, which is because more loading is on the rafters, king post and the bottom chords, so you can take less section, that is less section, less width section for these vertical and the inclined. Okay, so for these I will take that is, for this I will take 2 ISA double angle 45 into 45 into 5 mm. Okay, this is both for the vertical as well as for the inclined. Okay, that is for, okay. Okay, so this is my truss 1. Okay, after designing the truss 1, it's time to design the truss 2, which are 4 in number, and the length for the truss you can find using the quick command is 24 feet and half inch. Okay, so we will take the length equal to 24 feet for this truss. Okay, so length is 24 feet, so draw the bottom chord 24 feet. Okay, the rise of this truss should be same as T1. Okay, that is length of the this king post will be exactly the same for the truss, equal to the truss 1, because we have to connect these trusses at the top, that is truss T2 and T1 should have same height of king post. Okay, that is T1 and 2, because here we have to connect them, so truss T1 and T2 should be of a same height. Okay, so a height of T1 is 8 feet 6 inch, so for T2 you have to take it as 8 feet 6 inch. Okay, so 8 feet 6 inch will be the king post for this truss. Okay, join it with this. Okay, so this is our truss T2. Now the length of the bottom chord is 24 feet. Okay, I have made this truss as four sided. Okay, slope is on all the four sided, so that's why T1 will be in the shape of this, that is full triangle, and T2 it will be in the shape of right angle triangle. Okay, so the bottom chord is 24 feet. We will divide it into 6 equal gaps, so each gap will be 4 feet. Okay, so take the offset command from this, measure 4 feet. One, two, three, 4 and 5. Okay, so there will be 6 gaps. Trim this using the trim command. Okay, after join, incline it with the vertical to complete our truss. So this will be my truss T2. Okay, and they are 4 in number. Okay, so this is my truss T2. You can show the dimensions for this truss. So this gap is 4 feet. Actually, this line have not properly connected with this the bottom, so let's again okay, so all the gaps are 4 feet. Length of our rafter here will be equal to 25 feet 4.5 inches. Okay, can again measure it using the quick command. Yes, it's 25 feet 4.5 inch. And the king post, its height is 8 feet 6 inch. Okay, you can find the lengths of the rest of the members using the quick command. Okay, the first incline is 9 feet 4 inch and first vertical is 7 feet 1 inch, and similarly for the rest of the members. Okay, again for this truss, I will take the rafter, the king post and the bottom chord as ISA 50 into 50 into 5 mm. Okay, and rest of the member as 45 into 45 into 45 into 5 mm. Okay, so this member will be ISA 50 into 50 into 5 mm. Okay, that is rafter, king post and this bottom chord member. Okay, so these three are ISA 50 into 50 into 5 mm, and rest of the members, that is vertical and the inclined, will be 45 into 45 into 5 mm, because more weight is to carry by rafters, king post and bottom chord. Okay, this should be 2 ISA. Okay, not single section but 2 ISA 45 into 45 into 5 mm. Okay, also here 2 ISA, not ISA, that is double angle section. 2 ISA 50 into 50 into 5 mm. Okay, so this completes our truss 2. After designing the truss 2, now it's time to design the truss 3. Okay, so you can find the length of truss 3 as 8 feet 6 inches. Okay, and it is placed at the midpoint of the truss 2, so rise will be half of the truss 2, that is half of 8 feet 6 inch, which is 4 feet 3 inch. Okay, so length of the truss is 8 feet 6 inch, that is length of the bottom chord, and the king post is 4 feet 3 inch. Okay, so let's draw the truss 3. So length is 8 feet 6 inches, and king post is 4 feet 3 inch, because it is at the midpoint of truss T2. Okay. After that, you will divide the gap into two equal parts, that is 4 feet 3 inch. You will draw the vertical. Okay, and then you can join it to get the inclined member. Okay, this is my truss T3, and they are also truss T3, and they are 8 in number. Okay, you can count the number, that is 1 2 3 4 5 6 7 and 8. Okay, T1 are 2 in number, T2 are 4 in number, and truss 3 are 8 in number. Okay, their function is to brace these trusses, that is T2. Okay, they will carry much less load, so we can take less weight sections for these members of the truss T3. Okay, the length of the rafter for truss T3 is, sorry, it's inclined, is 9 feet 6 inches. King post is 4 feet 3 inch. Okay, and this gap is also 4 feet 3 inch. Okay, for all the members of the truss T3, I will take single angle section, not double angle section, but I say 50 into 5 mm. Okay, that is for all the members, that is uh, rafter, king post, bottom chord, and ties. That is 50 into 50 into 5 mm. Okay, because it will carry much less load, I am taking single angle section, but of section 50 into 50 into 5 mm. Okay, so this gives you how to get the trusses details of the truss for a roof of a building. Okay, you have to remember that first you have to draw the truss plan, then you have to fix the pitch or the rise of the truss. After that, you can start drawing the individual trusses. Then you can design these trusses in the STAAD Pro. Okay, or if you are experienced civil engineer, you can know that what type of section will be suitable in my area. If the loading is higher, you have to take the channel sections. Okay, but if loading is less, you can take the angle section or the hollow square sections. Okay, after designing these trusses, there are other 2 points which you have to take into consideration, that is the size of the gusset plate, which will gusset plate will fix where the members meet. Okay, so gusset plate size uh, for these trusses, I will take same type of gusset plate. So gusset plate size, I will take it as 8 mm thick plate. Okay, and its size I will take as 8 inch by 8 inch, that is 0.2 meter into 0.2 meter. Okay, this is the size for the gusset plate. Then you have to take the size of the base plate also. Base plate will fix below the bottom of the trusses. Okay, so for this building, you will have base plate one at this corner, one at this, that is total will be 1 2 3 4 4 and 4 8, 8 12, 16, after this 17, 18, 19, 20, 21, okay, 22. Okay, so 22 gusset plates will be required for this building, and its thickness should be more than gusset plate. So I will uh, take the size of the base plate as 12 thick plate. Okay, and let's take its size as 0.3 meter into 0 point, that is 1 feet by 1 feet. Okay, actual size of the plate can be seen at the site at what will be the ideal size, but 0.3 meter into 0.3 meter will be ideal for most of the cases. Okay, so 22 base plates will be required, and gusset plate you have to find for each truss that what type how many gusset plate will be required for each truss. Then for truss 2, multiply it by 2, truss 1 multiplied by 2, truss 2 multiplied by 4, and for truss 3 multiply it by 8 times over, because there are 8 number of T3 trusses. Okay, 4 number of T2 and 2 number of T1. Okay, so this is how you can uh, design the truss plan and get the truss details for a small building. Okay, for much higher commercial buildings you have to design the truss actually in the STAAD Pro or more advanced software, in which we will use the I sections for the rafters. Okay, but you from this video you can get the idea that how to design the truss for any small building. Okay, in the next video I will show you how to get the purlin plan for this truss also. Okay, so stay tuned for the next video, and like, share and subscribe to my channel, and also you can take the membership of my channel if you are a new civil engineer or you want to get the tips and the tricks that how to apply the civil engineering at the site. Okay, you can get in with me in personal touch if you take my membership plan. Okay, so also if you found this video helpful, please share this video with your friends, okay, so that they can learn also. Thanks for watching Master Civil Engineering, and stay tuned.